Going to solve GFG problem of the day, that is total decoding messages. So it's a GFG 4-point problem and we are supposed to do this in complexity O1 and time complexity On. So the question is, a message containing letters A to Z is being encoded to numbers using the following mapping. So A to Z alphabets have been given. For every alphabet, an integer value is given starting from 1. So one thing to notice, there is no 0. So if anything comes like 0, we have to directly return 0. So that you should keep in mind. And you are given a string digits, you must have to determine the total number of ways that the message can be decoded. So like you are given digits 1, 2, 3, and let's suppose there are total alphabets from A to Z, and as we know that if it start from 1 it will go till 26 because there are only 26 alphabets in total. So we can find possibility like 1, 2 or 3, or 1 or 23 or 12 or 3. So there would be total 3 possible ways to form this. Let me explain it with this C++ code. Let me initialize array size as n, and also let's put some base condition like if there are no elements in the array, or also if only the first element has value 0, we'll return 0, right? Because we cannot afford to have 0 because there is no value given for 0. Also we'll declare two variable as previous 2 and previous 1. So previous 2 is to decode 2 steps back and previous 1 is to decode 1 step back. Let me initialize this value as 1, and same will do for previous one. So we just gave this one because there is only one way to decode empty string, or if there is only first valid string, so there's only one way, right? Now we'll go to the for loop. We'll iterate from the second element, that is index I equal to 1, till last index. And once we go inside the function, we'll declare something as current, which is the current element, as 0. And we'll see if now we are doing this for a single digit valid case, like if we are forming a single digit, like we are not forming 23, we are just forming 2 and 3. It's like that. So if digits of I is not equal to 0, I mean it's fine, then we can add previous one in current. It makes sense, right? Then we'll take another case as a 2-digit valid case, that is if we are forming 23, then we'll write something as let's say 2 digits. Okay, let me write full. Now we will convert the string into integer, or I should say substring into integer. Hopefully you know this. And we'll do this to extract character from index I minus 1 to index I. That's why I put 2. And also make sure if 2 digits is greater than equal to 10, I will explain this part, and 2 digits is less than equal to 20, we'll add current plus equal to previous 2. And previous 2 we defined when we go 2 steps back. Okay, what I did wrong here. Okay, so if we are picking 2 digit, it shouldn't exceed 26, because if it's exceeding 26, it means there are no letters. We cannot do this way. We have to either form 2 or 6. Or also it should be greater than or equal to 10. I mean if it's less than 10, it's like 0, 9, we cannot form this. It should be at least 10. Now let me put previous to as previous one, and previous one as current. We'll go forward till the end of array like this, and we'll do these transformation. We'll check all the conditions till the end of the array, and at last we will return previous one. Let me check. Okay, there's array line number 23. What is it? If 2 digits greater than 10 and 2 digits is less than equal to, I should put this as 26. And also 2 digits is not declared. Hopefully it should run now. We are putting from 10 to 26. Right, it makes sense. Let me submit it. So yeah, thank you.